Greetings! In today's lesson, we will tackle double inequalities. Let's remember that a double inequality in math is an inequality where two inequality symbols are present in its notation. We mentioned that in mathematics, it is customary to write an inequality and read it, starting from the expression that is written in the middle. Let's illustrate with an example. If I mention that 5 is greater than the number 3 but less than the number 8, then this comparison is represented as a double inequality. In algebraic terms, it can be written like this. It is more than a certain number b but less than number c. Also, if we see inequality symbols, they can be of different types. They can be strict or non-strict. We can work with the following double inequalities. For example, A is greater than or equal to B but less than C. And I can provide many such examples, but we will solve the inequality. And as I promised, we will examine an inequality where a strict symbol is written in one case and a non-strict symbol in another. For instance, if I need to solve such an inequality, 6a is greater than or equal to 18 but less than 24. I need to find values for a in this inequality that will fulfill the conditions, the original inequality. How can we solve a double inequality? In solving double inequalities, we apply the same algorithm and rules as before that we applied when solving ordinary inequalities. That is, we can split the inequality by the same positive number or multiply the inequality by the same positive number. We can add or subtract the same value from both sides of the double inequality. For our example, we need to focus on the coefficient, which equals 6. If my variable is expressed with a coefficient and there are no other operations, then to solve this inequality, I must divide by 6. As a result, what will we get? 6a will be divided by 6. When I divide the expression written with a letter, I will divide the other sections as well. 18, I will also divide by 6. And I will also divide 24 by 6. Please note, the initial signs I recorded will remain unchanged. In this case, 6 and 6 I will divide by 6. As a result, 1 and 1 will remain. When I divide 18 by 6, I end up with 3. 24 divided by 6, the top will be 4 and the bottom will be 1. So I will get the letter A is no less than 3 but less than 4. We have identified the values of A that meet our initial inequality. However, we talked about how this notation represents the answer. But we must be able to show this solution. We display this solution on the coordinate line, marking points 3 and 4. Pay attention to point 3 is marked. And we fill in this point. Point 4 is an unfilled point. Consequently, our value A, it is greater than 3 but less than 4. Therefore, our solution lies within this interval from 3 to 4. Moreover, the number 3 will be a solution, so I write it in square brackets. However, the number 4 is not a solution. As you can observe, we followed the rule of dividing every part of the inequality by the same positive value. And let's solve another example together. I will write the coefficient for the letter as a negative number minus 6a. All other numbers will be written as it was before. As a result, we have this inequality. Minus 6 times a is greater than or equal to 18, but less than 24. So what changes in this case? According to our rule, we must divide by the coefficient, which is minus 6. Let's write it down. We divide by the number minus 6. As soon as I note that I'm dividing by a negative number, I instantly remember the rule that when dividing or multiplying by a negative number, the inequality sign changes. Let's write it down. If I divide minus 6a by minus 6, then the sign greater than or equal to will change to less than or equal to. 18 divided by minus 6. The sign less than will change to greater than. 24 divided by minus 6. This rule is vital for double inequalities. Generally, it applies to all inequalities. What do we obtain? It turns out that a is greater than minus 4, but less than or equal to minus 3. Keep in mind that while solving this inequality, I flip the signs when dividing by a negative number. Yet, the issue is that in math we noted it shouldn't appear like this. Thus, I will write this inequality correctly. And we always start with a being greater than the number minus 4. Thus, I will express a as being greater than negative 4, but less than or equal to negative 3. Then, when I show the solution to this inequality on the number line, the number minus 4 will be located to the left of the number minus 3. Then, the interval from minus 4 to minus 3 will be the solution to our inequality. We can express this as a numerical interval. A is in the segment from minus 4 to minus 3 inclusive. In today's lesson, we tackled a double inequality. Next time, we will address another double inequality. That concludes our lesson for today. Farewell until we meet again.